All right, so we're gonna be doing question LeetCode 98, validate binary search tree. So taking a look, it says, given the root of a binary tree, determine if it's a valid binary search tree, BST. So a valid binary search tree defines as the follow. The left subtree of the node contains only nodes within the key strictly less than the node's value, and the right subtree of the node contains only nodes with a key strictly greater than the node's key. So both left and right subtrees must also be binary search trees. So basically, in simple terms, you just look at the example, right? You have a root, which is 2, and then you take a look at its left and its right. So everything on the left has to be less than, and everything on the right has to be greater than. And this continues if the tree expands. So, 5, 1 is less than 5, which is good, but 4 is not greater than 5. So this alone makes the output false. So we know that for our output that we want to make sure that it is a Boolean, right? And we're turning true and false. So if anyone is, if you guys have done any binary search tree questions, most of the time, in order to traverse, we use recursion, which is basically just calling a function within itself over and over and setting conditions within. So with that being said, obviously we are going to create a helper function, right? Helper function. We're just going to call this traverse. And we know that we're going to have to pass in our root. We're going to call it node. And not only are we going to pass in node, but we need a way to make sure that any number to the left is less than and greater than. And we're going to pass in 2 more parameters, one being called low and one equal high, right? Within a recursive state, you're always going to have a edge case or base case or whatever people like to call it, which is basically very similar to what I'm going to write, or if not node, or no, if node is none, right? And in this case, we're actually returning true instead of false. Usually it's false, but if there is none, then we want to, if there's no node, then we do want to return true in this instance to fit all the examples within. So we're going to have that. And to make things a little bit easier, we're actually going to call this function below before writing anything inside, so we know what values we're working with within these parameters. And then we know for a fact that node is going to equal to root, so we can easily put that. But then these lows and highs are a little bit different. So we have this thing where if you write float, and within here, this is our low, right? So negative infinity and float positive infinity. So these values quite simply represent negative infinity and positive infinity, which allows us to, with this root, if we're in a particular value and we want to make sure that this value is less than or greater than, like overall, with that overall broad sense, this infinity kind of allows us to achieve that. So when we write a little bit more of the code, I feel like those parameters are going to come into play and be a little bit more easier to read. But continuing on, we need to write our test case, right? So this is basically the edge case is when we stop. Test case is a condition that we're trying to check every time we loop. So what that's going to look like is we need to be able to check if our root is if anything to the left of our root is less than and everything greater to the root is greater than. Or how we're actually going to write it is if anything to the left or left is less than our root and our root is less than or greater than. So that is how we're going to write this, and how that's going to look is if not, basically meaning if this is not the case, right? Meaning that anything inside here is probably what we want for it to look, because we're going to return false. So if low is less than node.value, right? And node.value is less than high. Oh, that's weird. Return false, right? So you see, if this is not return false, meaning if this does not happen, then we want to say, hey, this is incorrect. We want this to happen, right? So low, which is going to represent here, if this is less than our value, which this is binary search tree, or this is a binary search tree condition, good. And if our node.value is less than or high, which is another binary search tree condition, then return false. Beautiful. So now we have an understanding of what that wants to look like. Now what we need to do is recursion, right? We want to actually be able to pass down values to the left and the right. And the way we do that is by calling the function within. So we're going to have to do it once for the left. We're going to have to do it once for the right. And then once that's done, we're going to return left and right. Beautiful. Everything's coming together. Now all we need to do is the hard part. So we know that we're going to call the function. So we can call traverse here and here. But how are we going to fit these parameters? Well, the parameters are going to be a little bit different comparing to if it's left or right, because left, we're going to be grabbing the values from, here. We need to make sure that they're less than this. And if right, we need to make sure these values are greater than. So the low and high and the way that we set those variables differ. So if we're doing left, right, we are going to do this to make it a little bit easier. Our first value is our node, right? Our second value is our low, and our third value is our high. We know this because this is how we have it set up here, right? So we want to make sure that our low is less than our node, right? So our low is going to be node.left, right? And then our low is going to be low, which is the negative infinity here, and then our high should be node.value. And then we're going to stay here for a second so we can explain this properly. So node.left, right? This is our node. So our node.value, right? In this instance, we're looking at an example, right? We would draw it out here. So we have this gigantic explanation instead of that little screen. 2, 1, and 3, right? So node.left is our node, meaning that it's 1, right? Beautiful. It's 1. And then our low is the negative infinity, right? So is our negative infinity less than our node.left 1? This is true. Awesome, right? And is our node.value, which is node.left, right? So is 1 less than high, and our high is the node.value, which is 2, right? Because you have node.left and node.value. Left is 1, value is where we're starting, which is our root for the first case of the recursion, which is 2. So if we're checking left, meaning that if anything to the left has to be less than our main value, which is .val, high is the val, right? No.val is the left right now. So is 1 less than 2? Yes. This is the case, right? So we don't return false and we continue going. So this is correct, right? So with that being said, you see how we had to kind of angle those particular values into a way that it works. So now we're going to do it for high, right? Meaning like the other side, the right side. So our node, we're going to want that to be node.right, obviously, right? Our low is going to be node.value, and our high is going to be high because we want the positive infinity, right? And then how is that going to look? So we're going to do it again, right? So our low is node.value. So that's going to be here, right? This is our low. Low, right? And then is our node less than node.value, which for the right side is going to be is low, node.value, less than our node.right. Oh my god, sorry about that. Less than our dot value, right? Which we want this to be less than 3 because we're checking right. So this is true, and then it's 3 less than our high, which will be the infinity, right? No, it's not, right? So in that case, that's perfect, right? Or it is. This is less than infinity. Oh my god. Again, I'm sorry. This is very difficult to follow the recursion. But yes, this is less than the infinity, right? So what that's saying is as our low, the 2, right, is our root value less than our right? It is. Awesome. And then is 3 less than infinity, right? Our float infinity. Yes, it is. Perfect, right? So that means that it is not going to return false because it is not that. It is that. So we continue recursion and so on. So because it works for that, you see as it spreads out, the recursion follows the same practices. If it does hit, then we just return false because we're returning Boolean output. If not, then we just return left and right, which should be true. And because it returns true, it reaches the test cases where it is correct.